Okay. Wait, you want to throw away all the clothes that you don't use anymore?
Yeah, I don't know what to do with them.
But it's still reusable. We can do something with this prospective fast fashion waste.
It's good idea. Yeah, let's make this into our research.
Why not? Oh, okay.
Hello everyone, my name is Raysa Antoni.
And my name is Zakeisha Dhiannazwa Qomari. We are from
Semesta Bilingual Boarding School, Semarang.
So,
In this video, we'll present our ideas about the industrial waste that has negative impact on the environment. Fast fashion waste.
basically, fast fashion is a strategy used by many top textile industries that produce large quantities of clothes with affordable basic materials. This concept follows the latest temporary trends and provides the best response to consumer demands through pricing.
As we mentioned before, fast fashion has already had many bad impacts on our environment. The production process requires large amount of water and energy consumption, while the use of harmful chemicals causes water and soil pollution. Textile waste from unsold or unwanted clothing also contributes to the global waste problem. The short life cycle of fast fashion clothing, along with the greenhouse gas emissions generated during production and distribution, further exacerbates its impact on climate change. The United Nations named the fashion industry as the second most polluting industry, producing 8% of all carbon emissions and 20% of all global wastewater.
Wow, that's quite terrible. What can we do to handle all of this? Well, we plan to address the scarcity of fossil fuels by introducing EPF, express polyfuel. EPF is made from waste generated by industrial couches, specifically industrial couches that made from polyester.
We convert polyester cloth into biofuel using the pyrolysis method. This reaction involves the material decomposition at high temperatures without oxygen. So, the reaction resulting from this technique forms vapor or gas, which is later condensed into liquid products.
The research we conducted is located at AL Production and the Chemistry Laboratory of Gajah Mada University.
Then, how we do the pyrolysis process?
Well, first we have to do a preliminary temperature to determine what temperature we can use in the pyrolysis process. We carried out 5 experiments, namely at temperature of 300 degrees Celsius until 550 degrees Celsius. Based on observations, we can begin to carry out the pyrolysis process on polyester fabrics starting from temperature of 450 degrees Celsius, 500 degrees Celsius, and 550 degrees Celsius. Liquid begins to drip from the tip of the condenser at the 385 degrees Celsius. The liquid didn't burn, proving it was not oil. After the temperature was above 450 degrees Celsius, the liquid was tested again and successfully ignited when exposed to a match flame. From the first test we conducted, polyester clothing can produce pyrolysis oil.
After conducting the pyrolysis test, we performed characteristic tests on the resulting pyrolysis oil. The characteristics we tested included density, viscosity, calorific value, pour point, and flash point.
Density is the ratio between substance's mass with its volume. The higher the density of a fuel, the higher the efficiency energy and the propulsion on an engine will be better. Viscosity indicates the level of fluidity of a liquid fuel. Engine performance is influenced by the viscosity level of its lubricant. If the viscosity is high, then the lubricating properties will be good. Flash point is used to indicate the lowest temperature of an oil fuel at which there will be enough flammable vapor to support combustion when an ignition source is applied. It determines the safety of fuel use and storage. Pour point is defined as the lowest temperature at which the test fluid can be poured under the prescribed test conditions. A low pour point indicates that the fuel has a good ability to flow at low temperatures. Calorific value indicates the amount of heat energy released during complete combustion of a unit mass of a fuel. It shows the amount of oil fuel required by an engine in a certain period.
From the second phase testing regarding the characteristic of EPF, we discovered graphs like this.
Observing the comparison graph between the density test results of pyrolysis oil with other fuels shows that EPF with a temperature variation of 550 degrees Celsius has the potential to be used as kerosene. Furthermore, on the viscosity comparison graph, it shows that the viscosity of EPF almost reached the viscosity value of kerosene. And in the flashpoint comparison graph, the flashpoint test results of EPF cover the flashpoint value of biodiesel. In the pourpoint comparison graph, the pourpoint test results of EPF have a temperature that is too high and do not yet cover the pourpoint temperature of other fuels. Last, in the caloric value comparison graph, EPF with a temperature variation of 450 degrees Celsius almost reached the standard caloric value of biodiesel.
As a conclusion drawn from the graphs, the density, viscosity, and flashpoint test results indicate that EPF has the potential to be used as either kerosene or biodiesel. However, considering the pourpoint and calorific value, EPF still have relatively low quality to be used as kerosene or biodiesel. Further research can involve distillation of EPF to improve its quality.
Besides oil, pyrolysis also produces biogas that has the potential to be converted into LPG, as well as residue that can be utilized in charcoal briquette production.
In the further research, the liquid oil from pyrolysis can be used as vehicle fuel as well. That's all from us. Thank you for watching this video. EPF, your sustainable solution from fast fashion waste.